Alright, as I already explained, you're going to be watching this video and copying down your notes into your book as we go along. We should be on page 206 in our book, and we're going to be looking at the mid-segment of a triangle. So if we read the theorem that it gives to us right away, it states the triangle mid-segment theorem says the midsegment of a triangle is parallel to the third side and its length is 1/2 of the length of the third side. So if we take a look at our triangle, our midsegment will be MN. Alright, what is a midsegment? We didn't read that part at the top. A midsegment is the segment whose endpoints are the midpoints of the two sides. So that means M and N are both the midpoints, so if we wanted to show that, we can put those tick marks on our triangle. Just show that those pieces are congruent, and thus M and N are both the midpoints. Alright, so now that we have our diagram marked up, we know which one is the midsegment, that's MN. Let's look at part A. Part A states, complete the hypothesis and the conclusion for the triangle midsegment theorem. So, it just wants us to change our theorem up here, which I'm circling in yellow, into some actual statements, some conjectures. So, we say M is the midpoint of blank. What side is M the midpoint of? I'm going to pause here so you can think about it. You're correct. M is the midpoint of A, B. Remember to put that line segment symbol on top. Next, N is the midpoint of which side? Correct. N is the midpoint of side B, C. Alright, so that's the hypothesis of our theorem. Now let's look at the conclusion. Our conclusion has two parts. MN is our midsegment. What line is MN parallel to? Yep, AC. MN and AC should be parallel. We're actually going to try to prove that in a second. Next, it says its length is 1/2 of the length of the third side. So the MN now without the segment symbol, which means the distance between points M and N, what will that equal to? Yep, so we might have taken a couple more seconds to think about this, but MN is equal to 1/2 times the distance between A and C. That's why we don't need that symbol on top. Alright, so that is it for this part of the book. Now we're going to move on. Before we get started on the next part, I thought it would be good to actually look at a real triangle, because it's going to get pretty complicated pretty quick in the other proof. So if we look at A, its coordinates are -5, 4. B, its coordinates are -1, -3. And the coordinates of C are 5 and -1. I already found the midpoints for us. I did this on GeoGebra. The coordinates of E is 0, 1.5, and the coordinates of D are -3, 0.5. So we want to see real quick, are these lines in fact parallel? And are they in fact, is the midsegment 1/2 of side BC? So we can check if they're parallel real quick just by checking their slopes. So the slope for BC, their slope would be just like our normal slope equation, y2 minus y1 all over x2 minus x1. So here we would have let's just say C is the second point, we would have -1 minus -3 all over 5 minus -1. So that means we get -1 plus 3, so that would be +2 on the top. And on the bottom we would get 5 plus 1, so 6, and we could reduce that down to 1/3. Next up for DE, the slope. Alright, this one's going to be trickier because we have some decimals. We can say E is the second point, so we would do y2 minus y1 all over x2 minus x1. So 1.5 minus 0.5 all divided by 0 minus -3. So on top we would get 1, on the bottom we would get 3. No need to simplify here because it's already as simple as it's going to get. So we get 1/3 and 1/3 are our slopes. Since the slopes are the same, these are in fact parallel, so we can add those arrowheads to show that they're parallel. If we wanted to prove the distance parts, we would have to use our distance formula, and it looks like I can't write as small as I thought I could on here. So let me try to do it up a little bit higher. So BC would equal the square root. I might have to jump some steps here. So the distance from B to C, we can draw this triangle to help us think about this so I don't have to use a complete distance formula. We're kind of jumping some steps here. Usually we do x2 minus x1 to figure out what's inside the parentheses, but we can do that right ahead, and we would get 5 minus -1, so 6. And then we would add y2 minus y1, which here it's the 2. So notice how it's the same information from our slope equation. So inside we would get 36 plus 4, which we can rewrite as the square root of 40, which we can simplify to 2 times the square root of 10. So that's our third side from our theorem. Now if we go and do this for our mid-segment, we can do this with our decimals. So again, the distance between D and E, so DE without the line segment, that means distance. We saw above that we can just steal the information from our slope, so we would get 3 squared plus 1 squared. And again, that's because I can draw this triangle here, and we would have the 1 and the 3, so it's kind of like we're using Pythagorean theorem. It's kind of like we're using the distance formula, or we're just kind of skipping steps and being lazy. So we would get 9 plus 1, so that's a square root of 10. So we can see in this example triangle, our mid-segment and the third line are parallel, and the mid-segment is 1/2 of the third side. Or in other words, the third side is twice as long as the mid-segment because we have this 2 out here. Alright, so now if we actually move back to the book, it's going to ask us to do all of that now with variables. Oops, sorry, I skipped ahead. Alright, so now let's try to do all of that again, but now with variables. So find the coordinates of the midpoints M and N. There we go. So we just need to remember B is BK because I feel like my iPad's going to cover that up. We're going to walk through this pretty quickly. So find the coordinates of points M and N using only our variables. We don't have actual numbers here. So M is the midpoint of A and B, so that means we have to use our midpoint formula. To do that, we have to remember our midpoint formula. So that means M is going to be equal to, we're going to take the average of our x terms, so that means A plus B over 2. And then our y terms, which was H plus K over 2. So that's the coordinates of point M. Coordinates of point N, we would do the same thing. We would have B plus C, because we would add our two x terms together and then divide by 2. And then K plus L, because we would add our two y terms together. So here we go. We're going to go back to all the stuff we learned in Algebra 1 when we talked about literal equations. So now we have to find the slope of both AC and MN, which are the midsegment and the third side, the base of the triangle. So MN, let's do red for that. That's going to be our midsegment. So the slope is going to be, we have to take our y terms on top. So the y terms of M and then the y term of N. So we would do H plus K over 2. And then we subtract K. So we get, subtract the y term of N. So that's K plus L over 2. That's going to be on the top of our fraction for slope. So on the top, we can combine those fractions together and then simplify. So we'll get H plus L over 2. On the bottom, we do the same thing with our x's. So we have to do A plus B over 2 and then minus B plus C over 2. So when we actually do that, we can combine those fractions right away because they have the same denominator. And then simplify, we get A plus C over 2. When we do that real quick, we see divide by 2 on both the top and the bottom. So we can get rid of that. So H plus L on the top, and then A plus C on the bottom. So that's just the slope for our midsegment. The slope for our third side won't be too bad, but it looks like I ran out of space, so let's try to do this kind of weird. The slope is equal to y2 minus y1 on top, so So I messed up. This L should be negative and the C should be negative. All right. So now on this one we would do H minus L, and then over on the other side, for the rise over run for the run, we would do x2 minus x1, so we would get A minus C. So are these slopes the same? Is H plus negative L the same thing as H minus L? And is A plus negative C the same thing as A minus C? And the answer is yes. So our slopes are the same, which means our lines are parallel. So since slopes are the same, the lines are parallel. Alright, now we have to find the distances. This one's going to be even more complicated because we have to use a distance formula. So if we wanted to, which you could just check, we would have to do the distance of AC, which is going to be A minus C squared, and then add, if we did A first, then we should do H first, H minus L squared. But we could just recall what we learned on the other side. Because we're just pulling the information from our slopes, we already did y2 minus y1 and x2 minus x1 for our slopes. If we get the same slopes with the same exact information on the top and bottom, then our distance stuff, we can just plug it in and get the same. So our distances, are going to be pretty similar. But we do have this 1/2 part in mn, so we do get this. I just don't have enough space on this slide, so if you're interested, remember before the video started, I said in class that if you have any questions, you can see me in the back of the class at the big black table. If you really do want to see this part worked out, please see me back there, but we just don't have enough space on here, and I do not want to start the video over again. So we can just trust this. This would be how we would prove it. If we move on to the check your understanding, let's just look at these questions. Are the mid-segments of an isosceles triangle congruent? So, in this little diagram here, they give us an isosceles triangle, right? Both sides of the triangle, right? BC would be 11 in total. AB would be 11 in total. So this would be isosceles, and we could see here that the mid-segments, those wouldn't be mid-segments because they have to be midpoints. So that's not a good example here. If we drew an isosceles triangle, let's just choose a better number, let's say 14 on both sides. If we drew the mid-segment, we have to find the midpoints first. So the midpoint of the left and the midpoint on the right, the midpoint is the halfway mark, so that means everything is 7 because the midpoint divides it into 2 perfect halves, right? Which means are the mid-segments of an isosceles triangle congruent? Did we find the mid-segments? No, we found the pieces on the opposite side of the midpoints. So that asks if we did this right here, and if we found it down here, are all of those going to be congruent? We would need to look at this in a bigger picture. So let me erase this again. Let me redraw it so we can do this nice and big. Midpoint, midpoint, midpoint. And we have our mid-segments here. If it's isosceles, we can fill that back in with 7. We don't know if the bottoms are going to be 7, 6, 5, whatever. Let's just claim they're 3, so that way they're for sure. It's isosceles on the left and the right. Those are 2 sides that are equal to each other, but the base has to be different. When we find our distances of our mid-segment, remember we said that this mid-segment would be half of this. This mid-segment would be half of this. And this mid-segment would be half of this. So we have to look at which sides are congruent to each other. Is blue congruent to red? Or is green congruent to red? Or is green congruent to blue? If so, whichever one is true, then those will be matching. So if the blue side is congruent to the red side, then the red mid-segment will be congruent to the blue mid-segment. So think about this on your own. I'm sure you can figure it out now since we have that beautiful diagram. If you want to check your work, come see me in the back. So now for number 8. Given that sides DE and AC are parallel, we can see, is DE the midsegment of the triangle ABC? Explain. So we have to remember our definition here of midsegment, and would this be the midsegment? As I already pointed out, because I thought this was the diagram for number 7, for a definition of midsegment, what do D and E have to be? Right, D and E should be the midpoints. Are D and E the midpoints? No, since 5 and 6 are not the same number, clearly. So they are not the midpoints, so that means DE is not a mid-segment. So none of the things we learned about mid-segments would be true for DE, because we know for sure that it's not a mid-segment. For number 9, they did say that AB and CB are the mid-segments of the triangle. So now let's verify it using our coordinates. This is not enough space for me to do this on the iPad. So if you wanted to verify it, we kind of did an example like this previously. So if you want to just get extra practice using the slope formula and the distance formula, do so right now. Otherwise, we're going to move on to the next part of our notes, which are about the trapezoid. So this would be your homework that is due tomorrow. Remember, we have a quiz on Friday, and it's going to look like this. Number 12 is from Tuesday's information. 10 and 11 would be from what we learned today. Notice how in 10 we have all numbers, so we can use our information about that the midsegment has midpoints and so on, and our new information that the midsegment is half the size of the third side. We can use all that same information in number 11, but now it's a little bit harder because we have our variables. So try those out, but we're going to get started on some new notes, which are going to be about trapezoids. So, as we learned in class, we learned that a trapezoid is a quadrilateral with exactly one pair of parallel sides. Only one pair. The parallel sides of a trapezoid are both called the bases, and the non-parallel sides are called the legs. So we're using the same vocab word from triangles, but using it slightly different, and there is a reason behind that, which we'll see on the next slide. The pairs of consecutive angles that include each of the bases are called base angles. So let's actually draw a trapezoid and actually see this. So on your paper, your trapezoid doesn't have to look exactly like mine, and it might be better for you if you draw one so that it's not exactly like mine. But I drew two lines that were parallel and then just connected them. And then we have our vertices, TRAP. So now we have to label these. Our bases, it said the bases are parallel sides. So TR and PA were our bases, so we can just put B for base. Alright. Next up it said the non-parallel sides were our legs. So these were our non-parallel sides. So we would put an L there for leg. And now the trickiest part is the pair of consecutive angles that include each of the bases. So that means these two right here would be base angles. Alright. And then the other two would be another pair of base angles. Notice how I'm using different number of arcs because we don't know anything yet about if there's any relationship between these base angles. Alright, so again, here is one pair of base angles, and here's the other pair of base angles. This is different how it was in our isosceles triangle. We said the base angles were on the base, but now we're learning that the base angles are on the leg. So it's changing it a little bit, and we'll learn some properties tomorrow that will be about that. But now that we have some vocab words, let's try to look at one more vocab word before we're done today. So our last vocab word that we're going to talk about is called the median of a trapezoid. And that is the segment, again, just like the mid-segment in a triangle, that connects the midpoints of, this time it's the legs of the trapezoid. So MN would be the median because F and E and G, H are the legs, and M and N are the midpoints of those legs. So the trapezoid median theorem states the median, which we put as that green line, of a trapezoid is parallel to both of the bases, and its length is the average of the lengths of the bases. Alright, so if we look, they already gave us the hypothesis and the conclusion here. MN is the median, and they wrote it out, so we know that MN is parallel to FG, and MN is parallel to EH. And then here is what that second part of our theorem states. The side MN, well, the distance of MN would be half of FG plus EH. That's the formula to find the average. So what it wants us to do is, if we look at number 2, if we draw one diagonal in the trapezoid EFGH, we should be able to figure out, by using some other theorem, we should be able to prove this information. So let's draw it. It doesn't matter which one. It's just more natural for me to draw EG. So if we draw this diagonal, just like we were talking about yesterday, we usually draw these extra lines to make some triangles pop up that we can't see right away. We spent so much time on triangles that we can use triangles a lot quicker than we can any other shape. So we have these two triangles now, which I could color in, which we can see. We have this triangle on the right, EGH, and a triangle on the left, EFG. So when we're looking at this, the problem goes on to say, how can we use the triangle mid-segment theorem to justify our trapezoid median theorem? So when we're looking at this, we can kind of see it, so label this as X. We can kind of see that this line right here that I'm coloring in red, which is MX, looks like the mid-segment of the triangle on the left that's upside down, and the one that I'm coloring in with yellow kind of looks like it's the mid-segment of the triangle on the right, the EGH. So we can use our properties of our mid-segment theorem just to quickly prove this. So if I stick to red, our triangle mid-segment theorem would say MX is parallel to FG. So that proves right away this part right here, so we can check that off. And then we can also use the triangle mid-segment theorem to say MX is equal to 1/2 of FG. Let me change this to blue because I don't want to write yellow on white. So if we're using the triangle on the right now, our triangle mid-segment theorem would say NX is parallel to EH, which, just like the other one, that proves this part pretty quickly. But we don't get the second part quickly. We get NX is equal to 1/2 of EH. But I'm sure you can guess by now what we're going to do is try to combine these two equations to get the one that we're trying to prove. If we do this, we can say MN is equal to MX plus NX and that's technically by the segment addition postulate. And then we can do 1/2. Now we're doing substitution. 1/2 of FG plus 1/2 of EH. And if we simplify those, since 1/2 is the coefficient on both, we would get the equation that the trapezoid medium theorem states. So again, this is the case where I ran out of space on my paper, but if we combine those two terms, the 1/2 Fg plus 1/2 EH, we would get 1/2 of the quantity Fg plus EH. So the next thing the book wants us to look at real quick, number 3, we have the same trapezoid. Mn is still the median, just like on number 2. This is the median, which means M is the midpoint and N is the midpoint. We can use our properties or the trapezoid medium theorem to show each of the following. So if the measure of GFE is 42, so that means this angle right here is 42 degrees, then what would NME be, which would be this one right here, and what would MEH be, which would be this one right here. So I'm going to let you think about it for a second. Alright, so we know that F, G, and MN are parallel, and that's by the median, the trapezoid median theorem. So we can use our parallel line postulate. That doesn't sound right. Our corresponding angles postulate, which says if two angles are parallel and a transversal cuts it, then the corresponding angles will be congruent. So this angle right here is corresponding to this angle right here. So that means both of these are 42. So we can go in and write 42 for this. And then we can go in and say again that other base of our trapezoid was also parallel to our median. So now we're looking at these, and now if we can remember what type of angles this angle and this angle are, those were same side interior angles, and we said that those add up to 180 using the same side interior angle theorem. So then we would do, if we have 42, we would do 180 minus 42. So we get 136 for angle MEH. B asks us to write an equation and solve for x if FG is equal to 4x plus 4 and EH is equal to x plus 5 and MN is equal to 22. So if we do that real quick, right, FG, which is the base on the top, is 4x plus 4. EH, which is the base on the bottom, is x plus 5. And MN, which is the median, was 22. If we look back at our median, our trapezoid median theorem, we were given an equation that we can set up, which I'm going to try to save space and not write it and just say it, which would be that the distance of our median is the average of our two bases. So the distance of the median is 22 equals the average of our two bases, so that's 1/2 of, and then we can plug in our bases, so 4x plus 4, oops, and then plus the second base, which is x plus 5. So now that we have that set up, we can simplify inside the parentheses and then distribute the 1/2 and then solve for x. Ran out of space here, so finish that out in your book and I can check your answers, or we can check them right at the end of class before we all leave. Likewise, if we did FG is 19 and EH is 12, you can actually find FG if MN is 19 and EH is 12. We can find the distance of FG if it's easier for you. Replace FG with another variable like D or X, just so we can plug it all into the equation from our trapezoid median theorem and try it out. Our answers for B and C are not related to each other, even though we're using the same diagram to understand it. If we look at number 4, what property or postulate allowed you to draw an auxiliary line in item number 2? We're just getting asked what allows us to draw a line, which stems back to the very beginning of the book of how can we draw lines between two dots, and that was the ruler postulate. Alright, so those were our notes from 15.1, 15.2. This is to check your understanding. I want you to try this out on your own. Notice how I added some from that's not in the book, so I'll post this on the slide so you can have this up if you're not listening to the video, if you decide to come right back to the back of the room with me. Number 1 and 2 are just like the ones we did, but everything's laid out in the diagram for you already. So hopefully this was a better way of doing class. We'll see. I'll get your feedback tomorrow, kind of like I do now, to see if this helped you focus and if you feel like you're learning more this way than if we try to do notes as a whole class. All right, good luck.